So let us create a class as, let's say, see, we will be creating a bean class here because we want to deal with collection of objects. Okay, so let's say I'm creating a class here as a coder. Okay, and this class is not for execution. I'll be creating a lot of objects of these classes. Okay, and let's say here we have certain fields. So let's say private int CID, or you can say coder ID, private string CName, or you can say coder name, and private string, let's say tech. Okay, and after this we will have a constructor here. So we will take a constructor with fields, and we will take some setter getters also if we require. See, if when you are practicing it, please type all the things, setter getters and constructors. It will be a good practice. We will generate toString as well. Okay, so now our bean class is ready. Now what I want to do, I want to use this class object to deal with collection. Okay, so let's say here I will create a new class, and this will be, let's say, coder test class, or you can say coder sort class, sort coder class, whatever you want to create. Okay, here main function also will be there because we want to execute this class. It will be public static void main, okay, string of a. Okay, now here what is the first thing I will do? I will create certain coder objects so that we have some objects with us to create a collection. So I will say, let's say coder C1 is equal to new coder, and since we have a constructor with all the fields, so I will pass the value to constructor. So I will say 101 coder ID. Let's say coder name is we can give any name. Let's give some easy names, Jai, and let's say the technology is Java FS, means Java full stack. And a similar way we will create some 4-5 coders. Okay, this will be, let's say, C2 new coder. Let me give here 104. I will not give it in a order because we want to do sorting with these objects. Okay, and the name is, let's say, Kia. Now here the K is small, actually we will make it capital only, and the technology is, let's say, only Java. Let's say this is 102 and this is Priya, and the technology is, let's say, PHP. Now this is 103, and let's say this is Sia, and the technology is AI, and this is 104. Rather, we will make this one 104 and this one 103, so that we can actually understand that the sorting is happening. And then this one will be, let's say, Leah. This. Okay, so we have 5 coder objects with us. Okay, C3, C4 and C5. Okay, so we have 5 coder objects with us. Now what we want to do? Okay, 1 2 3 4 5 is not there. Okay, let's make it 5. Okay, so we have 5 coder objects. We will do what? We will create a list here. Okay, let's say list L1, or you can say coder list, whatever you want. Okay, is equal to new. We will create an array list of it. Okay, and this list will be of type what? We will make it type safe. So this list will be of type coder. Okay, it is not of any user inbuilt types. It will be of coder type. We will be importing all the packages here, all the classes. So after this, now we are creating a list, array list of type what? Coder, and I will be adding all the coders to this list. Okay, so I will say add, and I will be adding them one by one. So let's say C1, then L1 dot add C2, then L1 dot add C3, then L1 dot add C4 and L1 dot add C5. Okay, now we have a collection ready. Collection of object type what? Coder. Now I will simply print it first, and we will see what collection we are getting first. Okay, so we will print L1 and we will see what we are getting. Okay, so if you see the output here, we are getting the coder. Okay, see 101, then 105 means it is getting the output in the according to the insertion order. Okay, so 101, then 105, then here 102, then 104 and 103, like that. So we are getting a list, means we can work with user defined type also. It will give us the list. Why we are getting the output in this format? Because in the coder class we are using a toString. Okay, so when we are printing L1, it is taking object, or taking it object by object, and here the toString representation is there, so it is printing every coder in this format. Now what if I want to sort this collection? It is a list. Okay, so I will write here collections dot sort. Okay, and I will pass the list here, which is L1. Now if you see here, it is giving me some error here. Okay, earlier when we were working with a normal list where we were using string, it was sorting the list. Okay, it was not giving us any error. But if you see here right now, it is giving us some error. What it is saying, the method sort list is in type collection is not applicable for the argument list coder. Means the moment you will try to work with a user defined type, this sort will give you some issue. Okay, so What is the problem? Why it is giving some issue? Why? Because see what happens when you are working with a primitive type. It is already having some internal wrapper classes. When you are working with string class, that is also inbuilt. And we will see those classes. Okay. If you see, there is an interface which integer class implements by default. What is that interface? If you see, that is a interface known as comparable. Can you see comparable? And that is the reason we are being able to sort them, even by using a list or by using tree set or by using tree map, whatever. Right now also the collection which I am creating in the list, if I will create it as a set and I will create it as a map and I will try to use tree set and tree map on them, still I will get error. Okay, they will not be sorted. You can try that by your own. Now if I see the other classes, let's say I see string class. Where is string class? Here. We were sorting the string, right? If you see, string class also implements comparable. Comparable string is there. Okay, and if we open this interface, comparable interface, it takes a T type. Now this T type is what? It is a generic type, means what? Here instead of this T type, you can pass anything. Okay, string class, user defined class, coder class, student class, employee class, any class. Now if you see this interface comparable, it compares two objects. Okay, x y, such that x dot compare to y, and if it checks if it is less than or equal to 0. If it is equal to 0, equal to 0, that means the two objects are equal to each other. If it returns 1, that means first object is greater. If it returns -1, that means the second object is greater. Like that it does the comparison. Now you are not going to write the code for the whole logic, but at least you should implement this method, which is compare to, in your code. Then only you will be able to sort the code. Okay, if you can see compare to. Okay. You will get a null pointer exception if the specified object is null. Okay, and here if you see, it has written that how it works internally. Okay, so it is like, which is defined to return -1, 0 or 1 according to whether the value of expression is negative, 0 or positive. So this is the reason we are being able to sort the inbuilt classes, or we are being able to sort the primitive types, because they are already having this comparable with it. But we don't have comparable. Okay, so we will solve this problem. We will come here, and what we will do, we will go to our coder class, because there you see string class implements comparable. Okay, so right now which class we are dealing with? We are dealing with coder class. So we will go to the coder class, and here we will say coder implements comparable. Okay, comparable is in java.lang package. Remember, comparable and comparator, both of them have similar functionality, but they are little different. We will discuss comparable first, and then we will discuss comparator, and we will discuss that what is difference between them. So if you see the first difference, comparable is in java.lang package, comparator is in java.util package. So right now I am dealing with comparable. In the T type, I will pass coder, because right now I am dealing with coder class. And the moment you say implements comparable, here you get some error, because we have to give implementation to the method which is compared to. Okay, Now here if you see, we got the compare to method. So what it will compare? It will compare one coder object with another. It will take just one argument, which is coder. So let's say we will give here, its return type is integer if you see, because it will return either 0 or 1 or -1 according to what is the object. Okay, so here I will say here integer I is equal to, we will say here that, let's say coder dot CID. Okay, we have coder.cid. No, or you can say, since we are working with the same class, okay, so you can say this dot CID minus, we will take this object, coder object. Okay, if O is confusing you, we will take it as C. So we will take it minus C dot CID. Okay, and we will return this I. Now whatever it is, -1, 1, 0, accordingly it will return and accordingly it will sort. Now if you come back to coder test, here you will see the error is gone from sort method. Okay, the error is gone. Here in the list it is printing everything in one line. So I will just put it in coder by coder so that we can see a proper result. So what I can do for that, I can use the enhanced for loop. So I will say for which type of object I am dealing with right now, coder. So I will say for coder C is that what coder is dealing with, list L1, and I will simply print the coder. So I will say print C. Okay, I will execute it. And there you go. If you see the output here now, we are getting the sorted result. Okay, earlier see it is 101, then 105, then 102, like that. Here it is 101, 102, 103, 104, 105. Okay, it is giving us the coder object sorted according to the ID. Okay, why? Because here in the compare to, we are using ID. Okay, ID is also the natural order sorting, means naturally it is sorted by ID because ID considered to be unique. Name can be similar, technology also can be similar, ID will be unique. That's why mostly sorting happens according to the ID. So right now if you see, the data is sorted according to the ID and we are dealing with comparable.